Hello, this is Austin with Austin's Nerdy Things. Today we will be going over the final post in a series about how to deploy a Kubernetes cluster within Proxmox using Ansible. So it's been like 7 months since I last wrote about this, but I finally had some time to finish it off. Essentially I wanted to get a cluster up and running locally so I can learn it for DevOps and Kubernetes itself. So I don't have to pay a monthly fee to any of the cloud providers. You know, basic Kubernetes cluster, from what I can tell, is at least $50 a month, if not 100, 150, when you finally get things up and running. So, and first, this is a dashboard showing the virtual machines that we will be creating in an easy to digest format. So with that, let's jump on in. We will have to take a couple steps back. So the current state as of this blog post says that you should have 4 virtual machines in your Proxmox cluster ready to go with the SSH keys set, the hard drive expanded, and the right amount of vCPUs in memory allocated. If you don't have these, take a step back and get caught up. So I'm going to step all the way back and go through the creation of the Ubuntu Cloud Init template within Proxmox and move forward from there. If you already have that stuff up and running, then I will put a link in the video for you to skip ahead to where we actually start doing the Kubernetes deployment. Okay, so if you're still here, I will assume you want to create that template. So you can see here that we have a blank Proxmox cluster, with basically nothing in it. That said, I did go ahead and create a couple things. I did make a TF user. Let me get this screen split here. So I do have the TF user. I do have the TF API token. TF, of course, stands for Terraform. I do have the permissions assigned, and I did create a network for use within the cluster, VM BR17. So those are all documented in the previous blog posts. I do need those to proceed, so I just wanted to get those out of the way and briefly highlight them before jumping into the rest of the video. All right, so that said, we'll create the cloud init image. I did turn this into a script. You can just zoom on down to number 6.5, and I will of course put links to all this stuff in the video description. Okay, so I'm just going to copy that, and now I will turn it into a script. Create Ubuntu template. Go ahead and paste it in there. And so what this basically does is this libguest fs tools that it installs is just so it can install Qemu guest agent, which is required by Terraform. Other than that, it doesn't really do any installing. It does install that feature, and then it creates a template, imports the disks that is downloaded. It does download the latest focal cloud image. Sets a couple things and then cleans up. So that's all it's doing. Control O, enter, Control X, chmod +X to turn it into an executable file, and then we will create the template. And so it's going to go ahead and hopefully not update too many things. Okay, so yeah, this was already installed. I did already go through this once. So we'll skip ahead here a couple seconds until this is done downloading. So it's now done downloading. libguest fs is going to do its thing now. We'll installing Qemu guest agent, and Qemu is the virtualization used within Proxmox. So it's a way to enable communication within the guest. And we'll skip ahead again until this is done. All right, so it's just setting the stuff for the VM. Okay, so the script says next step, clone VM, then expand the disk. It also says you still need to copy SSH keys to the newly cloned VM. So our Terraform script is going to take care of that. But end result is we now have an Ubuntu 20.04 template that will be used by Terraform to create our base virtual machines. Okay, so next up is deploying Kubernetes VMs in Proxmox with Terraform. And so, long story short, there is a script here that is used to deploy a couple machines. So we define a provider. In the script that I have locally, I did bump the version. The provider is how Terraform communicates with the virtual machine host or the cloud provider if you use it in the cloud. Then we define some variables for the Proxmox specifically. And then within that, we're going to make a Qube server, give it a name, some other things, set 4 gigs memory, 2 cores of CPU, 10 gigabyte disk, and all this other good stuff. It's going to have an IP of 10.98.1.41 and another IP 10.17.0.41. And then we are going to also define Qube agent. These are the worker servers. We're going to have 2 of these. And these will basically be exactly the same, although the IPs are going to be 10.98.1.51 and .52. And we are also going to have the 10.17. And then I do have Qube storage here. I put in the blog post. I have not found a use for that, so we're not going to use it. Okay, so with all that said, let's see here. Main.tf is my Terraform that I'm working on. And so, okay, I'm actually going to have to change this up. We will be back when I have the API changed. Okay, so I had to change the API token back. I don't really keep track of those, and so I have to regenerate them if I switch things up. So as I mentioned, I did bump the version number. Define what your Proxmox server is, and also what the target node is. And I put the memory back to 4 gigabytes. Other than that, this is essentially direct copy paste from this blog post. So, okay, so back to the post, current states. So we still need to get these VMs created. So I'm going to save that. I'm also going to delete these old Terraform files because that's going to cause an issue. All right, so this is SSH'd into our Proxmox host. So let's do cd terraform cubes. Okay, and now we can do terraform init inside of WSL. Okay, so it's now initialized. Now we can do terraform plan to see what it's going to do. It says, okay, plan 3 to add. So those are 3 virtual machines we want. Here's Qube server 0. And scrolling up, Qube agent 1, and then the last one should be Qube agent 0. Yep, so it's going to create all of these things. So all we have to do is terraform apply. And then it's going to calculate the changes again, and then we're going to type in yes and hit enter. And it is going to start creating our virtual machines. So it takes about 1:20 seconds. From what I can tell, it takes about 1:20 seconds, no matter how fast the underlying hardware is. So we have the VMs created, and now it's going to go ahead and copy the disks, expand the disks, set some parameters, and those kinds of things. So we will check back in 1 minute when this is done. Okay, so looks like it took 1:20, 1:26. We now have our virtual machines created. Qube server 01, Qube agent 01, Qube agent 02. The agents are going to be the workers, and the server is going to be the master. So we are now done with the Terraform aspect of it, and we have the current state as desired. So we're going to be using Ansible to do the actual cluster initialization. if you define Ansible, it is a hypothetical device that enables users to communicate instantaneously across great distances. That is a faster than light communication device. There's a couple sci-fi books that use such a technology. I think the one that actually refers to it as an Ansible, at least the main one, is Ender's Game. A lot of you probably be familiar with that. So that's kind of sort of where the name came from, if I had to guess. So in our case, it is an open source software provisioning, configuration management, and application deployment tool enabling infrastructure as code. Okay, so there's two starting steps, I'll call them, both kind of equally important. Number one is we have to define variables. And so we're going to do pod CIDR, which is just defining an IP range for inter-pod communication. And then we're also going to define what the join command is, and also set the home directory. And if you've followed the instructions so far, the home directory will be home/Ubuntu, because we're using the Ubuntu user. The rest of these you can leave, that's fine. And then equally as important, and I said, and potentially a better starting point than the variables, is defining the hosts. And so there's another file where it's essentially just categorizing different machines. And so we have a category called all, which has all three of our VMs. The Cube server has one, and the Cube agents have two, because we have different tasks to run on the different machines. And so we do have the Ansible vars file created with exactly what's present over here, and for Ansible hosts is also the same thing. So those are ready to go. And now we want to pause and make sure Ansible can communicate with our virtual machines. We'll use a simple built-in module named ping to do so. Hopefully you are not unfamiliar with ping. Alright, so we're going to do Ansible-I is the input file for the hosts. So we'll do Ansible hosts.txt, and we want to run it on all. We want to run it as user Ubuntu. We want to run the module m ping, and then we hit enter. This is going to fail actually. So potential SSH errors. What's going on in the background is it's going to tell us that, actually let me just show it to you, SSH Ubuntu at 1098.1.41. Warning, remote host identification has changed. It's possible that this is because I have created these and destroyed them multiple times. The last time I connected to it, it had a certain host key. This time it has a new host key because we just created these. So what needs to happen is you need to delete, you need to run it with the recommended command here, ssh keygen-f, and then I think the f is the file, the r is the remove the previous host key. So we'll do 41, we'll do 51, and we will do 52. If you're running this one time, you will not have this issue. So okay, now we're going to try and ping again, and we have ping pong, ping pong, ping pong on our three Ansibles. Sorry, on our three hosts. So that is what we want, and we should be good to go here. We covered the potential SSH errors. Here are those commands that you need to run to take care of that. All right, so next up is installing the dependencies. So there's a good amount of dependencies that need to be installed. Some basics installation packages. So it's going to install all these, and then we're going to add the signing key for Docker. We'll add the Docker repository, and then we'll install Docker. We need to remove a swap file. Because I forget exactly why, but that's a required step. And then we need to add the apt key for Kubernetes as well as the repository, and then install Kubernetes itself. I actually need to update this post. I do have the versions specified. So let's actually look at this in the text editor. And I did add a greater than or equal to 0 for the swap, because I think there were some issues where the swap was not being disabled even though it was 0. So I need to update the blog post with that. But also I did specify the exact versions for the packages here. Other than that, it's exactly the same. By the time you see this video, the blog post will be updated as well. And then, so it installs these packages, and then it marks them as hold to prevent them from being updated when you do like an app update, app upgrade. And then we're going to restart kubelet, add Ubuntu user, and then we're also going to do reboot to apply the swap disable. So with that, we can run our next Ansible command, which is to install these dependencies. And so the last command when we did the ping pong is just Ansible because we're calling it and then specifying the module. What we are doing now is we are running a playbook. So I'm going to copy that, paste it in here. And so this is just saying Ansible playbook -I. This is the same hosts file that we created originally. We're going to use the same host file in every command. And then we just specify the file we want to run. So going to hit enter. This will take a couple minutes. So when this is done, we will catch back up and pick up with the next task. Okay, so that took 1 minute 37 seconds to run the dependencies playbook. We have 15 OK items and 12 changed items. So we have all of the dependencies ready to go. So next up is to install the initialize the Kubernetes cluster on the master. And for this, we of course have another playbook. And this one will be init cluster. And so we need to set Docker to use systemd for the C group driver. I forget what the alternative is, but this seems to work out easiest. And then restart Docker, and then we're going to actually initialize the Kubernetes cluster with kubeadmin init. And this will create a file that we will be copying into the home directory so that our user can run kube control commands without specifying the file every time. Then we're going to restart it. Then we're going to get networking with Kubernetes. You need to basically install a networking plugin for anything as far as I can tell. So there's a couple of them. I don't know enough about Kubernetes to know which ones are better than others. I'm just using Calico. It seems to be fairly popular. I did have 2 user check things in here. These are not necessary. I was fighting with applying the networking and stuff. It turned out that I wasn't copying this file correctly, the config file. So I got that resolved. These will not be in the blog post when you look, but they're still here for now. Then we're going to apply the networking. Basically, this the Calico networking, it downloads this file and it saves it to our home directory as calico.yaml. And then we run kube control apply that file. And we do the same thing with the dashboard, where it downloads the dashboard YAML file. I think they're called templates. And then we apply it. So next step will be to initialize the cluster with this command. And this takes a little bit of time also. It has to download the images from the internet at the beginning, so we will catch you when it is finished. Okay, so initializing the cluster says it took 51.3 seconds. So our the server master is now up and running. I think they call them the control plane masters in Kubernetes lingo. All right, and so it prints out, the information about the initialization, and it does show our join token here, but we will be getting that separately. So that is the next step, which is getting the join command and joining the worker nodes. So what this does is it basically runs this command, kubeadmin token create / -print join command. And this is just the command that would need to be run on each of the worker VMs to join it up to the cluster. And then what it does is it saves this to that file we had defined earlier. So next up will be to get that join command. All right, and so it has saved it. So if we do, actually we'll just do cat join command .out, and we can see here that we have our join command. And so you could certainly combine this and the next step, which is joining the workers, into a single playbook. So next up is join the workers. This sets Docker to use the systemd cgroups driver, and then essentially just runs that command. All right, and so that took 12.5 seconds. That is done. So with the 2 worker nodes / agents joined up to the cluster, we now have a full-on Kubernetes cluster up and running. It says wait a few minutes and log into the server and run kube control git nodes to verify they are present and active. So let's do that now. All right, so we have our nodes ready. Status ready, ready, ready. So the cluster is up and active, and we should be good to go here. So the cluster is now installed and ready. Next up will be to get the dashboard working. This is kind of nuanced here, so I'll go through it. I'm just following the steps from... is this the full dashboard? No, this is the full steps for the dashboard, but this is how to create the user stuff for it. So it does not recommend to give admin privileges to the service account, which is what we'll be doing. I don't know enough about Kubernetes privileges to make this more granular, so we're going to proceed anyways. So okay, so on the master machine, which should be called kube server-01. Make sure you are here. Create a file called sa.yaml with the following contents. And another called cluster role. You can of course name these whatever you want. Need another R in there. But if you do name them something else, then you need to make sure you change the file names here. So next up, we're going to apply that file, the .sa. So we have servers account / admin user created. We're now also going to apply the cluster role file. So we now have cluster role binding created. And then we are going to retrieve the token, which is this big long thing here. Make sure you stop before the username. Okay, so I have that copied. So next up is we have to do a SSH tunnel. And so this will be SSH-L, saying it's going to be on the local side of things. 8001 is the port. 127001 is localhost, and then we're doing 8001 again, and then the remote and the username. And so this opens up a SSH tunnel. So it's still running in the background, but we also have an SSH session open on top of the tunnel or alongside, somehow associated with it. So with this, now we need to execute kube control proxy to actually proxy the 8001 port through our tunnel. And so with that, what we can do is open up our dashboard, and now it asks how would we like to log in. We have that big long token that is on the clipboard, so I'm just going to paste that and hit sign in. Don't save. The initial view is blank because we're looking at the default namespace, which doesn't actually have anything in it. So we are going to look at all namespaces, and we can see information about our cluster. So we've got services running, we've got pods up, we've got deployments, replica sets. I am still getting the hang of what these things are called and what they do. I am by no means a Kubernetes expert, so the screenshot from the beginning of the post is of the nodes page, and so we can see we've got our nodes up and working. Our server is 6 minutes old, so we're good to go. So what to do next, I don't know, but I will look into that and let you guys know. Probably going to be doing some of the tutorials, the stateless stuff, pretty straightforward. The stateful, a little less straightforward. Try to get a blog going on here and just teach myself the ropes. So with that, we have concluded. We just went over all this. So with this last post and last step, we have concluded the journey from creating a Ubuntu cloud init image in Proxmox, using Terraform to deploy the virtual machines, all the way through deploying the Kubernetes cluster itself. If you want to do some discussion, you can of course comment on the YouTube video that you are currently watching, or you can leave a comment on the blog post, or if you're a Reddit user, you can head on over to the sub that I created for Austin's Nerdy Things. So I'm going to try and put a post for every video and or blog post that I do in there. And here's a couple of references as well that I used to get started. So I hope you enjoyed the journey. If you did, click subscribe. If you like this video, click like. And I hope to see you around for the next video. All right, thanks for watching.